This is a really great problem, one of my favorite kinds of problems, because you really don't need to do any work here because all of the work is done. It's right in front of you, and it's really just a matter of learning how to interpret the graph of a function. I know we haven't really talked a lot about graphs of functions and derivative graphs and things like that, but I just wanted to try to clarify a couple things. Number one, the rules for movement of a particular particle uh, don't change even if you're looking at the graph of the derivative, meaning the graph of the velocity or the graph of the position. The rules don't change. Okay. In other words, for part A, let's talk about this. So part A, when does the body reverse direction? Okay, well, if a particle is moving along a horizontal line, and that's what this shows. This shows the velocity, okay, the velocity of a particle moving along a coordinate, it says a coordinate line, so a horizontal line. Either way, it's moving back and forth along a line, okay? And we've talked about this. This is the section 3.4, in which we have position, velocity, and acceleration. So if a particle is moving back and forth, so let's say it's going to the right. If a particle is going to the right, it means the velocity is positive. Okay? If a particle is moving to the left, that means the velocity is negative. Okay? Well, there's only one other option for a particle to be doing something. It's either moving right, moving left, or it's stopped. Okay? If a particle, and when it's stopped, by the way, then the particle's velocity is 0. So velocity equals 0, meaning, I should write that neater. So if the velocity is 0, velocity equals 0, the particle is stopped. Okay, so that doesn't change. Whether we look at a graph of a velocity, or if we are looking at the equation for the velocity, it doesn't matter. So if the velocity is 0, the particle is stopped. And if the velocity changes, so if the velocity changes from positive to negative, it means it's going from the right, or to the right, and then it stops and it goes to the left, meaning the velocity changes from positive to negative. That means it changes direction. Okay, so that's changing direction, changes direction. Okay, so keep in mind, velocity changes positive to negative, goes from right to left, changes direction, or left to right, changes from negative to positive. Okay, well, let's take a look at the graph and let's see if we can answer part A. The graph shows that the velocity, remember this is the velocity is 0 at time 0. Okay, so the particle stopped. At time 0, the particle is stopped. Notice here that as time goes, remember, time is the horizontal axis and velocity is the vertical axis. So as time starts, okay, so time is always going to go from 0 to 1 to 2 to 3 and so forth. So here we see time equals 0 all the way to time equals 10. As time starts, as the clock starts ticking, the particle's velocity is getting bigger. Okay, in fact, when t equals 1, we see the velocity has a maximum of 3. Okay, now the velocity is decreasing here, but nevertheless, all of these velocities are positive. So everything above the t-axis, the velocity is positive. Okay, and then right here at time t equals 2, we see that the velocity has a value of 0. Right there. Let me do that in a different color. So right here is where the velocity equals 0. In fact, we can see it happens right there as well. We won't worry about the beginning and the end yet. But the velocity is 0 here. And then after t equals 2, in fact, between t equals 2 and t equals 7, we can see that the velocity is down here. The velocity is down here. Still moving right here, okay? But the velocity, everything underneath, let me erase some of this. Everything, ooh gosh, erased way too much. Everything underneath this t-axis is where the velocity is equal to 0, or is less than 0. I'm concentrating on too many things at once. So down here, everywhere underneath the t-axis is where the velocity is less than 0. Okay, well, what did we just say? We said that if the velocity changes, this is down here, I'm talking about down here, changes from positive to negative, it changes direction. And so that's exactly what we see here. The velocity goes from t equals 0 to t equals 2, as velocity is positive, and then after 2, velocity is negative. So right there at t equals 2, the particle went from positive to negative, so therefore at time t equals 2, the velocity changed from positive to negative, so therefore the particle changed direction. Now you should be able to spot another place along this graph in which the velocity changes sign. So the velocity changes sign right here at t equals 7. Okay, because the velocity goes from negative to then all these values above the t-axis indicate that the velocity has a positive value past t equals 7. So after t equals 7, the velocity here again is positive. So the velocity changed from negative to positive at time t equals 7. And so we would say that at time t equals 2 and at time t equals 7, the particle had reversed direction or changed direction. Okay, and then when approximately, it says for part B, is the particle moving at a constant speed. Okay, constant speed. Well, remember, speed is the absolute value of the velocity. So nevertheless, speed, you can see when speed is changing, and you can see when the speed is staying the same. And let's talk about that for a second. Here, if you start at t equals 0, and what I'm doing is I'm putting little dots on the velocity graph. The velocity is getting bigger, then the velocity is getting smaller. Velocity is still getting smaller all the way down here to t is about t equals 3. It looks like about t equals 3. Okay, is when the particle, instead of moving up or down, the velocity going up or the velocity going down, the velocity right here remains the same, so therefore the speed then remains the same. Okay, so let's see if there's any other places along the graph. No, here the velocity is getting bigger. Velocity is getting bigger past t equals 6. Okay, and then it gets as big as it can get again. So again, the velocity is 3 when t equals 8, and then back down to here. So the velocity is constantly changing all the way along the graph, except for right here when from t equals 3 about to t equals 6. Now we don't know for sure, but that's not the point. The point is understanding the graph. And so from t equals 3 to t equals 6, we see that the particle is staying at the same speed. Okay, what is that speed? Let me write that down. The speed then, just to make sure we understand, the speed, where is it? It's at 3, so it's the absolute value of negative 3, so the speed is 3. And I guess we could put meters per second. So we didn't need to do that, but I thought I'd just go ahead and do that anyway. Graph the body's speed from 0 to 10. So the graph is getting a little bit complicated here, but I'm going to go ahead and try it anyway. I'm going to try red, and I'm going to make a big thick red line here so we can see the graphs. If we wanted to graph the speed, noticing that as long as the velocity is positive, so anywhere here, so the velocity is positive here, positive there, but so the speed and the velocity are the same. However, down here between 2 and 7, t equals 2 and t equals 7, the velocity is negative. But so we have to, instead of going below the graph, we're just going to basically take the t-axis, and that will be a mirror image, indicating that we can plot a couple points as well. But you should try this on your calculator as well. When time equals 3, the velocity is negative 3, so the speed would be positive 3. So let's put a couple key points up here. positive 3 there. When the time equals 6, the velocity is negative 3, so the speed would be positive 3. And so basically we see that over the interval in which the velocity is negative, the speed is positive. And over the interval where the velocity is positive, well, the speed is the same thing. Okay? And so that right there, that red function there of all line segments would be the speed. Okay, speed. That's kind of obnoxious how big I'm writing that. Sorry. Let's go down here a couple. Yeah, there we go. So speed is the red graph. Okay, graph the acceleration where defined. Well, alright, so we're already almost 11 minutes into this. You know what I'm going to do? I'm going to switch slides here and scoot on over here. All we have to do to graph the acceleration is get the same x coordinates, or t coordinates I should say, 2, 4, 6, 8, 10. And then the acceleration of t is just the derivative of the velocity, and we saw the velocity graph. Well, in between t equals 0 and t equals 1, we could probably do it like this, from 0 to 1, so t is 0 to 1. What's the acceleration? Okay, well, the acceleration would be the derivative between 0 and 1. What's the slope of that line? Up 3 and over 1. So the acceleration would be 3. Okay, I didn't do this chart very well. Let's do this. No, I don't want to do it there either. But the acceleration is 3, and that means that, let's put 3 up there on the number line. There's 3. And the acceleration is just the slope. Okay, so the slope is 3. It's constant slope. Okay, and there's 1 right there. And then from 1 all the way to 3, you go down 3 and over 1. So the slope is negative 3. Okay, and the slope of the tangent line, or the slope of the curve at the point, is going to be the acceleration. And so we have the slope being negative 3. Well, I adjusted my chart here to hopefully make it easier for you to understand what the graph of the acceleration would look like. And keep in mind that the acceleration at time t is just the derivative of the velocity at time t. In other words, it's the slope of the velocity curve. So when you see the graph of the velocity, you just have to find the slope at every point, and then you can that would be the graph of the acceleration. Okay, so again, the acceleration is the derivative of the velocity, and the derivative is the slope. So if we want to graph the acceleration, we graph the slopes of the velocity. Okay, so I broke down the times in between 0 and 1. We found that in between 0 and 1, the velocity had a slope of 3. So if you think back here, the graph of the velocity right here is up 3 and over 1. So the derivative of this curve is the slope of this curve, and the slope of this curve is 3 in between t equals 0 and t equals 1. Well, likewise, the slope is negative 3 in between t equals 1 and t equals 3. And so we fill in the chart in between t equals 1 and t equals 3. The slope of the velocity curve is negative 3. If we look here in between t equals 3 and t equals 6, we see the slope is 0. So the acceleration has a value of 0. That's what it is. The acceleration has a value of 0. Okay, I'm 40 seconds away from the 15-minute mark. From 6 to 8, we look at the slope here, and again, it's up 3 and over 1, up 3 and over 1. So the slope of the velocity is 3. And then from 8 to 10, we have down 3 and over 2. Down 3 and over 2 would be negative 3 halves. And so, let's see, from 1, oh man, I'm coming down, I guess I have to finish this in the next video, sorry.